has yttrium, ytterbium, actinium, rubidium, boron, gadolinium, niobium, iridium, strontium, and silicon, and silver, and samarium, and bismuth, lithium, beryllium, and barium.
I'm going to start this video with a quick scenario. So imagine you are living in a time just before World War I. Anyone who's doing modern history would know, or hopefully should know, that the World War I broke out in 1914. So that's when World War I started. So you're living in time just beforehand. And you're also a very patriotic German chemist. So first of all, basically everyone knew World War I would happen. Right? So Germans, British, they all knew World War I will happen. And you're living in time just beforehand. And you're also a patriotic German chemist. Now, you also know that your country will face a problem. As soon as the war starts, your country will face a major problem. And that problem has to do with chemistry, right? So you're a patriotic German chemist, you want to help your country win the war, and you know your country will face a problem as soon as the war starts out. So first of all, what is the actual problem? Well, the problem is that we need to have ammonia or nitrates, because they are the feedstock for explosive and fertilizer. Remember a couple of videos back, I said that we can make, out of ammonia, we can make explosives and we can make fertilizers. What are explosives used for? Well, they're used for TNT and obviously all kinds of war material and war weaponry, right? So we need to have explosives for the war itself. And what can fertilizers be used for? Well, fertilizers can be used for farming. So farming means more food. And obviously if a country's at war, they need to have plenty of food. And the problem is that as the war started, there's going to be a problem when it comes to the supplies of ammonia and nitrates. So this person knew that the ammonia or nitrate supplies will be threatened as soon as the war starts. So again, what was the problem and what was the solution that this person thought of? Well, he knew that there will be a naval blockade that will block the nitrate imports from Peru. So you can see this is the map here. This is the map of just before 1914. And we have ammonia. So Germany itself didn't make its own ammonia or nitrates. It came from different parts of the world, more specifically from South America, from Peru, which meant it had to go past these different types of channels to get there by ship. And he knew that the British would have a naval blockade, which means here's Britain. They're going to block this area, which means nothing will pass through. And that was going to be a massive problem for the actual Germans, because that means no more nitrates will come into the country, which means they could make no more explosives and no more fertilizers, which obviously means that the war effort itself would be futile. Without explosives, you're not going to win the war. So what was his solution? His solution was, obviously, he's a chemist, and he figured maybe we can make the actual nitrates ourselves. Right? So the solution itself was to make our own. Because beforehand, we had the nitrates that came from Peru was actually from, basically I think it's from bird manure, which is more or less just bird feces. So they use these manure droppings from the birds to make nitrates out of it. So there was no industrial making of ammonia. So he figured he can make a process that would make ammonia within Germany itself, because Germany has no supplies of ammonia, and he knew he'd be cut off, or Germany would be cut off. And this person I'm talking about, this person that you had to imagine that you are, is someone called Fritz Haber. Now, in this name, even though you probably never heard it before, it maybe sounds familiar by now, because the actual process he came up with is called the Haber process. And he did that before the First World War. The first plant was in effect basically in 1913 in parts of Germany. So they made their own nitrates by 1913, just before the war broke out. Now, the reason why I mention all this is because the dot point itself says gather and process information from secondary sources to describe the conditions under which the Haber developed the industrial synthesis of ammonia and evaluate its significance at that time in the world history. So we have to talk about the conditions, and these are the conditions here, right? He knew there was going to be a blockade, he knew there was going to be a lack of nitrates coming into the country, and he knew that for Germany to win the war, they needed to get these nitrates to make fertilizers and explosives. So he needed to have a process that he can use in his own country to make these ammonia feedstocks, which he then could use to make these different types of products. So that was the actual conditions. War was about to loom, and he needed to come up with an idea that could bypass this import, because imports weren't going to be happening because of the naval blockade. And that was the actual conditions, basically. That's the first part. And remember, it says that to describe the conditions under which Haber developed, so Haber in this case, it's Fritz Haber, the person who came up, or was partly responsible for coming up with the process, developed the industrial synthesis of ammonia. Because again, ammonia was around beforehand, but this is the first time we made it on an industrial scale. We actually made it on like a lab and inside a production facility. And the second part is, which we're going to talk about in a second, is evaluate its significance at the time in world history. I'll talk about that now. But also, because it's actually a gather and process information from secondary sources, what I'll also have attached in the descriptions, where I'll do that in future from now on, I've got a couple of just websites, so secondhand sources, that you can read through that go over that same kind of material. Because obviously .point says so it'd be a very good idea, I guess, just to always attach a couple of websites. They're not too long. If you want to read for them, go ahead. It's a good idea. Alright, so the second part I said was evaluate its significance at the time in world history. So first of all, I quickly want to talk about, again, the actual process. It's either called the Haber process, or often it's also referred to as the Haber-Bosch. I spelled that wrong. I should know how to spell Bosch because I am German. That's how you spell Bosch. The Haber-Bosch process, and the reason why it's named after two people is because two people were actually involved when it comes to making this process. The first one was obviously Fritz Haber, and he was a chemist, German chemist, who developed these ideas in the early sort of part of the 20th century, before the World War I broke out, so before 1914. He was born in 1868, died in 1934, and he was the person who came up with the process in a lab, right? So he had, on a small scale, he came up with the idea of how you can use how you can use nitrogen and hydrogen gas, and with the right conditions, so the pressure and temperature being right, how you could make ammonia from that. That's what Fritz Haber did. He did it in a lab, so on a small scale, so you can see the equipment in the back. That would have been his contribution. He made that machine, so he could do it on a small scale. But obviously, once you have it on a small scale, you still need to be able to put it into the big scale. And that was the job of Carl Bosch. Carl Bosch was also a German chemist who was working with Fritz Haber. So he basically took his ideas, his early lab ideas, so took the small scale ideas and made it into a big scale idea. So a big scale implementation, right? So this is the big scale plant that he helped produce. And this is the big scale plant right here. This is that one that was opened in 1913 and helped make a lot of ammonia, which then could be used for the war effort. That was 1913. That's why it's called the Haber-Bosch process, because they both contributed towards making this an industrial process. And what also been quite interesting is that Fritz Haber won the Nobel Prize in 1918. He won the Nobel Prize in 1918 for his contributions to the Haber process. And Carl Bosch won a Nobel Prize, I think it was in 1930, I probably got that wrong, 1938. I'm really bad with numbers. But he got it, I don't think he got it for the actual Haber process, but he got it to do with pressure, he dealt a lot of pressure, and obviously there is pressure involved in the Haber process as well. So he just perfected his ideas, and he got the Nobel Prize for that in 1938. All that was a side story, but the main part of, evaluate its significance at the time in world history, because Germany now had more food, so they had more food and more explosives. That meant that the actual war could go for longer and longer. If you look at the actual time frame of World War I, it started in 1914 and went to 1919, although most of the fighting itself ended in 1918. But the idea was that Germany itself more or less suffered a lot of famine, and there's a lot of problems when it comes to resources already in 1917. And without this Haber process, the war itself would have ended earlier. Right? So without this process that was developed by Carl Bosch and Fritz Haber, the war would have ended probably 1917 or maybe even 1916, because the war itself might have been delayed because it couldn't have started without these ammonia supplies. So the main idea, one of the big impact significant in this time, so it says evaluate the significance at the time in world history, so at the time where this came up with, it prolonged the war. It made it longer because there was more food available and there were more explosives available. Both of them are essential when it comes to the prolonging of a war. Also, another sort of impact was that it caused more deaths. So obviously because the war is longer, that's really one reason why it would cause more deaths, but also because now Germany had explosives and lots of explosives, and these explosives were used a lot in World War I to kill a lot of people. So the contribution of the Haber-Bosch process at the time was that more people died because of the prolonging of the war and because of the increased usage of explosives on the German side. So these are obviously not very nice things to be sort of tied to, having the war being longer and causing more deaths. But that's one of the big contributions of the Haber-Bosch process at the time in world history. But it also gave the blueprint of the Green Revolution, and I'm quickly going to talk about the Green Revolution. But what the Green Revolution is, it's all about increasing productivity. It actually started a bit later. It didn't start in in World War I, but increased the production of farmland so that we can produce more food for every sort of square land we have. So increase the production of farmland, and that obviously would mean we have more food. If we have more effective, more fertile land, and that means the actual ammonia that we could make from this, again, it was used for explosives, but also used for fertilizers. And these fertilizers make the actual land more fertile. And this was one of the main contributors to the Green Revolution. We need to have fertilizers to be able to make the farmland more productive. And if we have a more productive farmland, we have much more food. And what does that mean when it comes to much more food? If you look at, if you go to a shopping center now or your supermarket, you're going to see the food itself is quite cheap. Right? It's quite affordable. And that's why. Because of the Green Revolution, it was so much easier to make food, which is why the food prices went down significantly. And that also caused the explosion in terms of the population explosion. So if you think about how many people we have now, we just hit over 7 billion people. That was, I think it was less than 2 billion at the start of the century, so maybe just 100 years ago, I think it was less than 2 billion. In that time, we more than threefolded our numbers, increased by threefold. So that's what a part or a major contribution of Fritz Haber and Karl Bosch was this blueprint for the Green Revolution. But that came after war, but during the war is more about prolonging the war and causing more deaths. But afterwards, he also caused more sort of goodness by giving more food. But last but not least, I quickly do want to talk a bit about Fritz Haber as well, because he's a controversial figure. I said he was very patriotic, so he wanted Germany to win the war. So not only did he work on this ammonia power plant, but anyone who's done modern history would know that gas was used a lot during World War I. Your chlorine gas and your mustard gas, and Fritz Haber was actually a person who came up with it. So Fritz Haber was the first person who developed the use of gas, and he was he wanted Germany to win the war, and he came up with gas as a solution to help kill more people. So Fritz Haber was responsible for a lot of deaths, and his wife was actually so against it that she committed suicide just before the war ended, I think. But yeah, she committed suicide as kind of a disgust towards her husband, who was constantly working towards technology that would cause more deaths. So Fritz Haber, even though he won the Nobel Prize and he obviously came up with this great Haber process, he's very controversial because he's also contributed to a lot of suffering for a lot of people. He also invented the gas, which was later used in concentration camps in World War II, and which would obviously lead to the extermination of lots of Jews. And so he was responsible for the gas used in World War I and the gas used in concentration camps in World War II. So that's a bit about Fritz Haber, just so you know that he's a bit of a controversial figure, and people often wanted to take away his Nobel Prize for that reason as well, but they decided not to. But overall, what you should know from this dot point is the significance in terms of world history, time in world history, of this contribution of the Haber-Bosch process. It helped prolong the war and cause more deaths, because now they have more food and more explosives. So that was kind of the negative part. But it also gave the blueprint for the Green Revolution, which meant that we could use these fertilizers to increase the production of our farmland, which means we have more food, which means we can more easily feed our population. And the other part was talking about the conditions under which Haber developed the industrial synthesis of ammonia. There was the naval blockade, which was going to happen once the World War I started, and he knew that. He wanted to make sure that there was a constant supply of nitrates, so he could make more explosives, but it was going to be blocked by that naval blockade because it came from Peru beforehand, which is part of South America, so it had to be transported by ship. So to overcome that problem, he just figured out, if we find out a way that we can make it on an industrial scale in our own country, then we won't have to import it. So that's what he came up with, the Haber-Bosch process, which was pretty much came up with to help Germany win the war effort. But yeah, hope that was useful.
Thank you for watching.